Great. Thanks very much, and thanks for this invitation. So I'm pleased to talk to you about, to do an introduction. I'm not going to explain all climate simulations and the ENES data distribution infrastructure, but I would like to give you a flavor and an overview of what it is. So I myself, Sylvie Joussaume, I am a researcher in climate modeling from CNRS Institut Pierre-Simon Laplace in Paris. And I'm the coordinator of the H2020 project, which is called ENES-RI, ESGF for the infrastructure for the European Network for Earth System Modeling. So modeling, and I guess most of you are from the climate modeling background, so it's just to make sure that we start with the basic view. So those models of the Earth climate system, the Earth system models, they are key tools to understand and predict climate variability and change, representing the atmosphere and ocean, with here in the middle represented with the grid spacing, and representing from the top left the atmosphere with the clouds, the bottom left the ocean dynamics, top right the interactions with the land and vegetation, and bottom right the interactions with human activities. So the main aspects we are going to talk about are the access to the international coordinated experiments, which are from the World Climate Research Program, which are called CMIP, but also CORDEX for the regionals. So CMIP, hands-on for coupled model intercomparison projects. Those simulations are quite known because they are the ones that provide the projections and predictions on which the IPCC assessment reports are based. But CMIP is much beyond just providing projections and prediction. It is really this overall triangle based on a clear evaluation of models. So several simulations are allowed to have a good evaluation of the models. Also, several of the experiments that are there to help better understand different mechanisms, different processes. So it's really the overall which builds CMIP. So the exercise the most recent exercise is the 6th CMIP exercise, CMIP 6, with 23 under what we call the MIPS model intercomparison projects, which are represented on the diagram on the right, where you have some experiments that help to answer, to test, to investigate the answer, the response to forcing. So they are there to better understand the system. There are a set of experiments that are there to evaluate the system, like a better understanding systematic biases of the models, and a set of oops, sorry, Maria, I guess we hear some noise.
Right, I hear it too. Someone has the mic on. Don't do that, someone.
And some experiments that are there to provide prediction and projections, like the scenarios or the decadal prediction, and making sure that we have a good interface with the impact, so providing all the data that are necessary for impact studies. CMIP 6, it's a very big exercise. It starts, the first paper is 2014, explaining the overall concept. The paper by Ehring et al. 2016 is the one that described the overall CMIP 6. In Europe, we have 7 full Earth system models, and one more devoted on the ocean, another one on chemistry, but more limited on some process studies. And you have to realize that per model, it can be 20 to 50, up to 20 to 50,000 simulated years. So it's very extensive exercise, producing about 13 petabytes distributed among the different models. More than that's for the already for the European part, about 2 billion hours of computing time. So it's quite an enormous exercise. But that's a lot of knowledge which is behind that can help, and I guess that can be of value for you. I've tried to summarize what is the international status of those CMIP6 experiments. It's not all the CMIP6, I have concentrated on what we call the deck. So those are the core of the experiments that is required, which has simulations like simulated experiment forced by observed sea surface temperatures, simulations with some key like 1% CO2 increase. So a deck, a central part of the experiment. So there are more modeling groups that have done participated to CMIP6, but they are more focusing on some specific aspects. So those are the most extensive models that have done many of the CMIP experiments. In Europe, you find the 7 plus the one from AVI, which is on the ocean. So you have the Max Planck in Germany, AVI in Germany, but focusing more on the ocean. In France, the CNRM and IPSL, the Italian model CMCC, the UK ADLE, UK ESM, the Norway with NOR-ESM, and the European consortium ECAS. And so you have 8 in Europe, 1 in Russia. You have 7 in China, 1 in Taiwan, 3 in Korea, 2 in Japan, 1 in Australia, 5 in the US, 1 in Canada. So it gives you 30 modeling groups. And each of those model groups usually run several versions of their models. So that's about 59 models. If I count all the modeling groups and all the models, that's 38 modeling groups and 100 models. But the ones that are listed there are really the ones that provide the most of the data, most of the simulations. So just to give a few results, so CMIP, it's a lot of science. Here, for example, a paper using the ESM-VAL tool that will be also mentioned later. That's an evaluation tool which is developed in Europe. You have a range of diagnostics on top left, the simulation of the last historical period from 1850 until 2014, showing you that the overall models are able to simulate the trend of the last century, which is the black line. On the right, you have the comparison with different variables like surface air temperature, and when the correlation is 1, that means that it's very good compared to observations, so very good in temperature. And second is precipitation, showing that you have more variability from one model to the other. You also see that the orange part, which is CMIP6, has a better score than CMIP5 in blue and CMIP3 in black. So at each time that we do an exercise, the models are improving. So I'm not going to comment all those diagnostics, but there are many papers that are coming out in 2020 and this year on analyzing all the results. Top down left is their sensitivity. So the answer the models have when you double the CO2, what is the response, equilibrium temperature response. And you see that CMIP6, which is here in green, has a wider range with higher sensitivity than the previous one, CMIP5. With those models, you can also have other types of analyses, like the projections. That's a paper by Tebaldi et al., which shows you CMIP6 compared to CMIP5, and that due to this higher sensitivity, we tend to have a higher range in 2100 for the high scenarios. Below down, you have for another example, which is the last glacial maximum, comparing the last glacial maximum CMIP6 or PMIP4, that's the same cycle, and PMIP3, which was CMIP5. And you see that there is also a trend to have a weaker cooling, in that case, in CMIP6 compared to CMIP5. So a lot of science that can be done with all those model results. So who are we in ENES? ENES, this is the European Network for System Modeling, and ES-ENES is the infrastructure of ENES. What we call the infrastructure are the climate models themselves, but also the tools that are needed to develop and analyze the models. We have the high-performance computing, and the data and metadata. Today, we are concerned by these data and metadata, and ES-ENES support this infrastructure, supports the access to the CMIP and Cordex international experiments, and also supports some sharing of expertise on climate models, on tools, and high-performance computing. You have the website is is.enes.org, and for ENES, enes.org. To support CMIP and Cordex, ES-ENES is the community that does the support to what is called Earth System Grid Federation. So the Earth System Grid Federation is the data infrastructure that allows to disseminate, to distribute all the CMIP and Cordex data. You see on the left all the nodes, and we have a bunch of those nodes in Europe. And ES-ENES does not only support the node, we also contribute about half-half between the US and Europe to the development and to the maintenance of this infrastructure. In the middle, you have, excuse me, a diagram of this peer-to-peer, P2P infrastructure, which is a distributed infrastructure where you have functionalities on each node, either just a data node distributing the data, but also some others that are index nodes, so allow to have search and provide access to the data, identity provider, and more also the development of the compute node, and those are in the pink ones, and the compute node is what is really the main topic of those 2 days of training. ESGF, this is an enormous amount of data. It's about 23 petabytes of data, including a part which are replica. And for CMIP 6 itself is already 16 petabyte and some replica, and including the replica. So without replica, it's 9, really the core 9 petabyte of data. And there are over 15,000 registered users. So those data are fair, and Carsten will tell you more about this aspect. And all the software and the standards which are behind are open source software, and we use common standards for metadata and data. This is done internationally and with their multi-agency support in the US with the Department of Energy, DOE, the NOAA, NASA, in Europe, ES-ENES, and in Australia, NCI. And those data are also, ES-ENES helps, those data can be accessible through the Copernicus Climate Change Service. So it's only part of the data, mainly the historical simulations and the projections, and really a subset of those which are available through the Climate Change Copernicus Service. And ES-ENES providing, making sure that there is an ESGF node in this Copernicus Climate Change Service that allows to access those data. So the different services for data access, we have services that are to their users, like you are today, but also to the providers to make sure that they indeed are able to provide the data. This is for this round mainly CMIP 6, but the first ES-ENES was on CMIP 5, the second on Cordex, and the third on CMIP 6. So we provide access to ESGF data. We help the publication, provide citation, DOIs, and there is also a long-term archival and replica. There are compute services, and those are the ones that you are going to have more described during those training. There are also services on data and metadata standards, on the CF convention, for those that know that. This is the Climate Forecast Convention, on the data request to make sure that the data follow the same, all the model intercomparison project know which data to store. Model documentation, ESDoc, and we also have a portal dedicated for the climate impact studies, so an easier access to ESGF. Let me show some of those. So on ESGF, to give you an idea of the amount of data flow, here is a statistic provided by CMCC on the use of the European ESGF nodes, so it's only from the European nodes. You have in yellow the not EU users, and in brown the EU users. And you see that through time there is we were in the range of the 100 terabyte for CMIP 5 and Cordex, and now we are more in the range of the 500 terabyte per month of data that are downloaded each month and supported by our nodes. ESDoc, and I would like to advertise on that because I think it's not used as much as it could be, where there is really a tremendous effort to document the intercomparison experiment, the MIPS, the models, all the different models, and also the different experiments. And all that is accessible in es-doc.org. And there is also an errata service that explains when make corrections and explain when there are when somebody finds some errors in the data set. So it's an enormous amount of work by the community. So please have a look to ESDoc. The Climate for Impact portal, climateforimpact.eu. This is so the idea is to have to help explore climate data and perform analysis. So a bit like you are doing, the one that you are following the training here is to directly access ESGF and use the larger computing resources. Here for the impact community, the idea is to simplify, to have simplified ways of doing, for example, computing different climate indices and perform calculations. So this is another tool that we have. The models when they run, so the different models, when they run the simulation, they store their data on their platforms. Then they provide the data in the ESGF nodes. This is the right bottom. But on the top right, there is also the development of platforms where you can have data pools, large data pools with multimodal data and computing associated. And those are the compute service that you are going to be concerned by this training. We have 4 of those. You are going to have DKRZ and CMCC, but there are also some accessible at the CEDA in UK and IPSL in France. We also have, if you really want to have much more access to much more computing time, we have also some dedicated calls. It can only be on selection, but then you can have access to larger amount of computing, but really similar to what you're going to test, but at a much larger scale. And of course, if you want to do analysis, you also need to have access to analytical software. And ENES also supports their climate data operators, CDO, that are developed at the Max Planck, and that allow to have some tools to help doing some analysis of the results, and also the ASM-Val tool, which is a community diagnostic and performance tool. You will also hear about another one, Ophidia, that is developed by CMCC, and that will be accessible through the compute service of CMCC. So this is the main messages I wanted to give you, and I really hope you will enjoy the training, that it will be useful for you. And I would like to thank the organizers, in particular Maria, that has done a lot of work to ensure that this training occurs, and Paola for proposing to have it jointly with EOSC-hub. Thank you.